What comes into your mind when you hear the word bacteria? It might be a disease, an infection, that they are dangerous. On the other hand, you might think about beneficial bacteria that are associated with many health benefits. However, what you would never imagine is that there are some bacteria capable of generating electricity from waste. Yes, you hear it right. There are some bacteria that can produce electricity when they consume organic pollutants. In my research, I took advantage of this type of bacteria through the use of microbial fuel cells. But what is a microbial fuel cell? It's a device that basically consists of two chambers connected by a wire. In the first chamber, we will find the pollutant and bacteria. Once bacteria start to eat the pollutant, three products will be released: CO2, protons, and most important, electrons. These electrons will be transferred from the first chamber to the second, and this electron flow is what generates the electricity in the system. Now, let's talk about what kind of pollutants can be used to feed bacteria in a microbial fuel cell. Wastewater from different sources have been evaluated. In my experiment, I used contaminated water from one of the most polluting industries in Canada, the oil sands industry. Oil sands are a mixture of oil, water, and sand. And the process required to separate the oil from these oil sands requires the addition of large amounts of water. Just to have an idea of how much contaminated water is being produced, for every barrel of oil produced, we require 3 barrels of fresh water. All this contaminated water is stored in tailing ponds in Alberta. From a distance, tailing ponds look like an ordinary lake, with the big difference that they contain toxic water that represent a risk to the environment and to the human communities in those areas. Based on this, I took 2 components of the tailing ponds in my experiment. The first one, I took bacteria naturally found in this contaminated water, and the second, I took one of the main toxic pollutants, which are naphthenic acids. I placed both of them in a microbial fuel cell, and I evaluated the rate at which bacteria consume the pollutants and the electricity generated during this process. The results pointed out that electricity generation was higher when bacteria ate the pollutants faster. In addition, this electricity can be used to sustain the treatment process. In other words, no extra supply of energy would be necessary with these microbial fuel cells, which make this a cost-effective solution for the treatment of this water. So, next time you think about bacteria, remember that they can turn toxic pollutant into electricity. Thank you.